Without it, ships may be paralyzed. It's the nose of the ship. It sucks in seawater and then send it back to the ocean, just like human breathing. It's the sea chest. Without it, the generator will overheat. The main engine will seize. It becomes an underwater tomb at any time. The tank's structure is very simple. Looks like an inwardly concave box, hidden below the waterline on the side or bottom of the hull, the fence on the outside. It's a real lifeline. Seawater flows through it, through the pump and filter, distributed to various key systems on board, cooling the main engine, supplying generators, and supporting the firing system, and even provides water for deck cleaning and bearing cooling. But stable water extraction from the sea is not easy. The first thing to overcome is the static pressure force. Even if the ship is completely stationary, the seawater can automatically flow into the tank. This is why ballast tanks are usually designed as low as possible. A deeper one means more reliable water intake. The hull needs to be reinforced to withstand the extra pressure. This is a problem that hull designers must balance when the ship starts to sail. The second force, dynamic pressure. Sticking your hand out of a moving car window. The faster it goes, the greater the thrust of the air. The pressure generated by the hull cutting the water will push more seawater into the water tank. According to Bernoulli's principle, the fast-flowing seawater hits the opening of the tank. The deceleration pressure will further increase, which helps the sucked in. But new problems come out. If the water flow is too fast, it may suck in bubbles, debris, or even air. When the ship is heavily loaded, the hull sinks. The low-level sea box can work efficiently, but when light loads, the low-level seawater tank may be exposed, causing water absorption failure. A double water tank designed with one high and one low, ensuring the continuous inflow of seawater. The shape design is also crucial. Sharp edges or abrupt transitions can cause turbulence, forming vortices, and even trap bubbles, which will cause trouble for subsequent pumps and chlorine. So designers will smooth the edges of the box, or even cut the water inlet wall diagonally. Let the water flow gently in, maintaining a stable laminar flow state. The choice of location is a science. When the ship is sailing, a layer of turbulent boundary layer will be formed. If the sea box is too far back, it will fall into eddies and bubbles, and even cause cavitation, eroding the metal with microscopic shock waves. If it's too far forward, it may not flow effectively by fast water speed. The best location is the stable flow area in the middle, with the redundant design of double sea boxes on both sides. Even if one side is blocked or the ship tilts, the other side can still work normally, but the challenges of the sea are far from over. Seaweed, plastic bags, and shell larvae blocking the flow. Many ships have electrical and mechanical failures. By the sea box is blocked, causing the machine to overheat. Designers designate multiple protected layers, using thick steel grilles to block large debris. The internal mesh filter captures fine, small plastic fragments, algae, and shells. The system uses copper anode copper plus green to suppress the growth of barnacles and mussels. In polar waters, the challenge becomes icing. To ensure the temperature above freezing point, use the heat from the engine to prevent icing. For warships, not only to prevent clogging, but also noise, the water intake chambers are designed with compartments. Their shapes are also optimized to reduce sonar echoes, avoid detected by the enemy. Active maintenance is also important. Shipping companies regularly send divers underwater to clean up debris and check for damage. The ship will enter a dry dock, fully clean, repair, or replace the seawater tank parts. Nowadays, the defensive seawater tanks has entered the era of intelligence. Modern ships will monitor the pressure of the seawater tanks, flow rate, temperature, and even vibration. Once abnormal pressure drop is detected, the system will immediately warn. Crew can take timely measures to avoid the fault from expanding. Thanks for watching.